Today we are looking at practice test 4 of the official SAT practice tests, and we are looking at the math calculator section only, and specifically only problems that would fall under the subscore problem solving and data analysis, and there are 17 of them. Number 3. If a 3-pound pizza is sliced in half and each half is sliced into thirds, what is the weight in ounces of each of the slices, given that 1 pound is equal to 16 ounces? Well, the first step is to convert the 3 pounds into ounces. So if we start with 3 and we multiply by the conversion factor of 16, we know that the total pizza weighs 48 ounces. The next step is to slice the pizza in half. So we take our 48 ounces divided by 2, and we are left with 24 per half. So we have 24-ounce halves, and these are sliced into thirds. So we divide this by 3, and our final answer is 8. C. Number 4. Nick surveyed a random sample of the freshman class of his high school to determine whether the fall festival should be held in October or November. Of the 90 students surveyed, 25.6 preferred October. Based on this information, about how many students in the entire 225-person class would be expected to prefer having the fall festival in October? To find the precise answer, we're going to use this 25.6%. And when we convert that to a decimal, it looks like this, 0.256. We could multiply that with a calculator, or we could just observe that 25% is the same thing as dividing by 4, approximately. So if I divided this by 4, about what do I get? Just a ballpark figure, somewhere around 56. We're not even including that 6 thousandths, which tells us 60 is our best answer. Number 5. The density of an object is equal to the mass of the object divided by the volume of the object. What is the volume in milliliters of an object with a mass of 24 grams and a density of 3 grams per milliliter? So the formula they're talking about is density is equal to mass divided by volume. Now they're looking for the volume, and they give you the mass, and they give you the density. So we can replace D with 3, and we can replace M with 24, both of those from the givens. How do we solve for V? Well, since we're dividing by V on the right, we can multiply both sides by V, which pretty much does this, moves it over. And then if I want to figure out what is V all by itself, I divide both sides by 3, which cancels out 3 over 3. And on the right, I'm left with V is equal to 8. So the best choice is B. Number 7. The table above represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and the Motion Picture Association of America rating. What proportion of the movies are comedies with a PG-13 rating? So if I look at the comedy column and follow that down, and the PG-13 row and follow that over, where they meet is at the number 4. And they tell you here there are 50 total movies, or it's down here in the bottom. So 4 over 50. If you don't notice that in the answer choices, that's because this is not the least common form of this fraction. In fact, if we divide the top and the bottom by 2, we end up with 2 25ths. A is our best answer. Number 9. The table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, if a registered voter who was 18 to 44 years old in 2012 is chosen at random, which of the following is closest to the probability that the registered voter was from the Midwest region? The 2 key pieces of information are 18 to 44 and from the Midwest. But look at our age categories. The first one is 18 to 24. The second one is 25 to 44. So in fact, to figure out 18 to 44, I need to take both of these columns. So first for the total, that's right here on the bottom, I add these two together, and I get 62,662. Now how many of these are from the Midwest? I add these two together, and I get 14,690. Since this is the calculator portion, we could divide this out and get a very precise answer. But this is about 15, and this is about 60. 15 goes into 60 about 4 times, so it's about 1/4. B, 0.25, is the best answer. Number 10. What is the life expectancy in years of the animal that has the longest gestation period? The gestation period is here along the x-axis, so we're looking for the dot that is farthest to the right, and it's right here. The question is, what's the life expectancy? So all we have to do is trace this back over to the y-axis, and we see that it's 3. Number 11. Of the labeled points, which represents the animal for which the ratio of life expectancy to gestation period is greatest? So first let's notice that not all points are labeled, only A, B, C, and D are. And if we draw a line like this would represent pretty much a 1-to-1 ratio or 1-to-1 slope. Every time the gestation period goes over 1, we go up 1 life expectancy. Now the scale isn't perfect. In fact, we're going over 5 at a time, and we're only going up 1. But this still tells us pretty clearly what the answer is. A is the only point that is significantly above this line. That's why it has the highest ratio of life expectancy to gestation period. If that explanation doesn't make a lot of sense to you, you could take the value on the y-axis here, such as 7, and divide it by the value on the x-axis, and do this for all 4 points. And you'll find that A is the largest such. 13. Which of the following best describes the relationship between time and the estimated population of mosquitoes during the 20 weeks? Well, as time goes by, the population is increasing. So that rules out B and D, because decay means decreasing. If we look by how much we are increasing every 5 weeks, we see that at first it's 900, and then it's 9,000, and then it's 90,000, and then it's 900,000. That is not linear growth. Linear growth, you increase by the same amount each time. So C, exponential growth, is the best choice. Number 14. The expression above gives the amount of money in dollars generated in a year by a 1,000 deposit in a bank account that pays an annual interest rate of R%, compounded monthly. Which of the following expressions shows how much additional money is generated at an interest rate of 5%, then at an interest rate of 3%? Choice A is tempting because we see 5 minus 3, the subtraction of the two interest rates. It seems like that would be the right answer. However, because we're taking it to the 12th power, we end up with 2 to the 12th, which is very different than 5 to the 12th minus 3 to the 12th, for example. So we know A is wrong. Division is also not the appropriate way to do it here for B. And for C, dividing the entire ratios, or the entire formulas, are not correct. Choice D is the best answer. Number 15. Which of the following scatterplots shows a relationship that is appropriately modeled with the equation y is equal to ax to the power of b, where a is positive and b is negative? Let's look at a test case, choosing some numbers, such as 2 for a, because 2 is positive, and maybe negative 3 for our exponent. Remembering how we deal with negative exponents, this actually becomes y is equal to 1 over 2x cubed, which means as x gets larger and larger and larger, the bottom of our fraction gets larger, and we're actually decreasing in size. So we can rule out C and D, and it's down to A or B. Which of these looks like exponential decay? Well, it's B. A is more linear. Number 20. The mass of living organisms in a lake is defined to be the biomass of the lake. If the biomass in a lake doubles each year, which of the following graphs could model the biomass in the lake as a function of time? Note, in each graph below, O represents 0, 0. So first let's talk about D, where the biomass is not increasing at all. That's definitely not doubling. And if we look at choice B, there's just, bam, a whole bunch more biomass, then no growth. Then bam, a whole bunch more biomass, then no growth. That's not really realistic to how biomass or living organisms populate. It's not spontaneous, I assure you of that. So we're down to A or C. And there's two possibilities here. A is kind of like this parent function here, y is equal to x. And on a graph, we see linear growth, and it's increasing. It would be increasing by the same amount each year. So it's not possible to double beyond the first year, which is why that's incorrect. For choice C, we're looking at a different type of function, where we have some initial starting population A, and it's being multiplied by 2 to the power of x. In other words, this is how it doubles each year. What does that parent function look like? It looks like this, C. 21. In a scatter plot of this data, where renewable energy consumption in the year 2000 is plotted along the x-axis and renewable energy consumption in the year 2010 is plotted along the y-axis for each of the given energy sources, how many data points would be above the line y equals x? So let's actually plot this out. We have 2000 on the x, 2010 on the y equals x, it's level 1. I'll make my scale 1, 2, 3, and 1, 2, 3. Biofuels in red in the year 2000 is much, much smaller. So when I plot the point for biofuels in 2010, it's way above y equals x. For geothermal, it's going to be just above the line because this bar on the right is slightly higher. We can start to see the pattern here. And notice that for hydroelectric, the 2000 is actually taller. So the 2.75 is going to be larger than the 2.5 of the 2010 and will be below that axis. And we see here this one is also below, so we are only looking at these three. C is the best choice. 22. Of the following, which best approximates the percent decrease in consumption of wood power in the United States from 2000 to 2010? So our value in 2000 was 2.25 because we followed the line over and that's where it hits the axis. And in 2010 it's on the line, which is 2. So we go from 2.25 to 2. How do we find the percent decrease? Like this, 2.25 minus 2 all divided by 2.25, and we multiply our result by 100 to convert it into a percent. If we use our calculator to do this, we end up with about 11.1%. Thus, B is our best choice. 23. The tables below give the distribution of high temperatures in degrees Fahrenheit for City A and City B over the same 21 days in March. Which of the following is true about the data shown for these 21 days? So let's walk through them one at a time. Here for choice A, the standard deviation in City A is larger. Well, we see that this frequency of 14 means that there are far more days where the temperature is 79 compared to anything else. When things are way more spread out across the different temperature ranges, that means that actually City B has a larger standard deviation, because that's what standard deviation means, the spread of the data. So A is wrong. C, a similar idea that the standard deviation is the same. That's also wrong for the same reason. And can it be calculated with this data? Well, yeah, it can. So in fact, B, the standard deviation of temperatures in City B, is larger. 27. The relative housing cost for a U.S. city is defined to be the ratio average housing cost for the city divided by national average housing cost, expressed as a percent. The scatter plot above shows the relative housing cost and the population density for several large U.S. cities in the year 2005. The line of best fit is also shown and has the equation y is equal to 0.0125x plus 61. Which of the following best explains how the number 61 in the equation relates to the scatter plot? So if we look along the x-axis here, 25,000 is a very dense area to live. And as a result, the housing costs are higher. And here at 5,000, there's more of a rural area, or at least not as dense as the 25,000. And what happens to the housing cost? It decreases. But as we continue to go left on this graph, do we ever get to 0 for housing cost? No. That's because D, even in cities with low population densities, housing costs were likely at least 61% of the national average. 31. A partially filled pool contains 600 gallons of water. A hose is turned on and the water flows into the pool at the rate of 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? To phrase this in y equals mx plus b, we can identify our slope, m, as 8 gallons per minute. Our b value, or our y-intercept, is 600 gallons because that's how much we start off with in the pool. and our x value, or our time, is 70 minutes. So I plug in 70 for x, and 8 times 7 is 56. We'll add the 0, plus 600, and this gives us 1160. 33. The pes, a Roman measure of length, is approximately equal to 11.65 inches. It is also equivalent to 16 smaller Roman units called digits. Based on these relationships, 75 Roman digits is equivalent to how many feet to the nearest hundredth? To convert these, we're going to start with 75 digits and multiply this by the fraction of 1 pes per 16 digits, and we're going to multiply this by the fraction 11.65 inches per 1 pes. So at the end, digits will cancel out, pes will cancel out, and we'll be left with only inches. So we multiply straight across the top, 75 times 11.65, whatever we get, we divide by 16, and our final answer is almost there, because we also have to add this last conversion to convert to feet, and we get 4.55 feet, because they ask us to round to the nearest hundredth.